Okay, so this is 1249 minimum removes to make a valid parenthesis. So given a string of open and close parentheses and lowercase English characters, your task is to remove the minimum number of parentheses in any position so that the resulting parentheses string is valid and return any valid string. Formally, a parenthesis string is valid if and only if it is the empty string containing only lowercase. It is the empty string contains only lowercase characters, or it can be written as A, B, A concatenated with B, where A and B are valid strings, or it can be written as A, where A is a valid string, right? So minimum, so we have a string that may have imbalances in parentheses, which makes it an invalid string, and we need to clean it. Let me write that down. Goal, given a string, an unbalanced invalid set of matching parentheses remove as little as possible to make it valid, right? So basically, given a string, it may or may not be invalid. We need to remove as little as possible. We need to remove as little characters as possible to make it valid, right? So here we have the input here. That's the code. Here we're going to remove one. Okay. So now we create a string. So what is what are our questions here? So basically, an empty string should return true. Empty string or no parens should be true. What else? What else? An empty string. I guess we can assume the input is always a string. So input is always a string. What else? Nulls should be handled by being true, right? So how do we solve this? Strategy. Here's my sticky note on what I should be doing at each step. Just making sure I don't skip steps. Strategy. Strategy. So of course we need to iterate over the string. Let's call it ideas. What is like a sensible way, right? So we can remove. So we can remove our parentheses from the string and then put it in a parentheses checker function. Remove parentheses. So remove parentheses. And then check parentheses, make note, and put it in a valid parentheses checker, right? I don't know if that actually guarantees. Well, anytime that we have on unbalanced parentheses, they just need to be equal on the left and right, right? So if we have 3 opens, we also need 3 closes, right? So if we can go through a string and we have 3 opens and 5 closes, we know the minimum is 2. So anytime that we have an unbalanced string, we just need to balance it, right? And how do we do that? So basically, this is going to be space. So it's going to be time. P, where P is the number of parentheses, times N, where P is the number parentheses, and N is the length of the string. And so time is going to be P times N, where P is the number of parentheses and N is the length of the string. And the space is going to be O times P times N as well, because anytime that we remove parentheses, we want to check it. And then in Java, anytime that we modify a string or change it, it creates a new string. So we're just going to have to do that over and over again. That doesn't seem very efficient. So can we do it in one pass, right? So the theory behind the valid parentheses is basically we can use some sort of stack if we come across a basically if we come across an open or a closed parentheses, we have 2 choices, right? So in the stack, we're going to keep an open. We're going to keep the so iterate over the string. Now we're going to have a couple of cases. So case 1. So A. So car C. Character is a letter. So character is a letter. Car is a, and then car is a closed parentheses, right? So we're gonna iterate with strings. What do we do if character is over letter? We're gonna skip it, right? Doesn't matter. Skip it, doesn't matter. We're looking for open and closed parentheses because we need to check if it's valid. So if it's open, we add it to a stack. Add to stack. If it's closed, we're going to check if our stack has any opens. We need to check if our stack has any opens. Check if our stack has any opens. What do we do here? If not, we delete it. Not we delete it. Else remove open from stack. At the end, in the valid parentheses problem, we need to ensure that we have the equal number, right? So what happens if we iterate over the string and we still have parentheses in it. That means those also need to be deleted. So at the end, delete all opens in stack, right? And what that does is it should essentially give us the string with the minimum amount of parentheses removed. So now we need to return the string. So we need to rebuild the string. Since Java is a little funny, we need to figure out like an efficient way to remove the strings. We can put everything in a string builder. Put everything in a string builder. Well, if we think about it, what are we asking? Whenever we iterate over a character in the string, we have a binary choice. Do we delete it or not, right? So we can keep a Boolean array. So we keep a Boolean array that marks true if the index needs to be deleted. All right, and then afterwards we create a string builder. We create a string builder that iterates over the entire string, and it iterates over the Boolean array if it's true, we skip it. If it's false, we add it to our string builder, and then we're going to return the new string, right? So if true, skip index, else add to string builder, return string. And that's going to give us a time of O of n. We only time and space, and where n is the number of characters in a string. So our time is O of n. How do we get O of n? We only need to iterate. We iterate over the string once, and then we iterate over the Boolean array, which is the same length as a string. Since we're not doing any compounded for loops, it's going to be n plus n, which reduces down to O of n. Okay, and then our space is going to be O of n as well. And that's because we need to keep a Boolean array of the same size as a string to track which indexes that we need to take care of. Okay. Right. So what does this look like? If s dot is empty, we can short circuit this one here. Our edge cases. So our test, empty string, return true. Empty, return true, right? Return S. Okay, so now we need to create the Boolean array. So Boolean indices. N is equal to s dot length. A new Boolean. So now we're going to create our Boolean array of size n, and that's automatically going to instantiate every index to false. We also need to create a stack, and that's going to hold an integer. Stack is equal to new stack n, and now we're going to iterate over the entire string. So for int I equals 0, I is less than n, I plus plus. If, so let's create a car C equals s dot car at I. So if C is equal to open parentheses, we're going to add the index to we're going to add the index to our stack, right? Else if C is equal to, now we need to check some logic if we're at an open parentheses. So else if C is an open bracket, if stack dot is empty, stack dot is empty, indices I is equal to true. That marks up we need to remove it. Else it's a valid one. Stack dot is empty, right? We need to, what else do we need to do? Oh, also, right, so stack is empty. We also need to check for else if, oh, now we pop from a stack, so we need to pop from a stack. So we need int index is equal to stack dot pop, right? If s dot car at index is equal to okay, does not equal an open bracket. We're going to mark that one for deletion as well, or else it comes or else we do nothing with it, right? So index is equal to true. So if so that should be it. So now we need to say if, so while stack is not empty, right? We need to mark every indices in indices stack dot pop is going to be equal to true. That's going to mark every open bracket for deletion, right? And then so now we're going to create our string builder. SB is equal to new string builder. For int I equals 0, I is less than n, I plus plus. If not indices I, SB dot append s dot car at I, and that's going to add the character at the index that needs to be that doesn't need to be deleted, right? So and now we're going to need to return the string, right? So return sb dot toString. All right, and what does that look like here? So let's use this input string for, we'll use this input string as a dry one, right? So S is going to equal A, close bracket, B, and open bracket, C, close bracket, D. So essentially, we know we want our output to be A, B, parentheses, C, parentheses, D. That's going to be our best case answer, right? So our Boolean array, indices is going to equal what is the, well, n is what? 1, 2, 3, 4, 5, 6, n is equal to 6. F 2, 3, 4, 5, 6, right? So here's our starting indices. We're going to create an open stack. And now we're going to iterate. So I is equal to 0, right? Let's copy this to make it easier, right? So when I is equal to 0, C is equal to A, nothing. Stack is equal to 1. That's going to be an open bracket, right? That's going to make us mark 1 for deletion. So at the end of this, we're here, right? It's going to go, so C isn't an open bracket. It's not going to push. It's going to go into our second check where C is in open parentheses. Since our stack is empty, it's going to mark that index for deletion. This is going to throw an error here, so we need to fix it. So else. So let's just turn it into an else if. Turn it into an else, actually. Stacked out pop. There we go. So we catch that little error there. So index is equal to stacked out pop, right? Indices index 2. This is equal to 3. 4. 5. Let me just paste everything there. Next is equal to 3. C is equal to 4. I'm a little scatterbrained here, so I'm going to leave what's left of the string here. C is equal to B. We continue. Right. It's equal to C over D. This should be it, right? Let me make sure. I'm kind of getting all, I'm all over the place right now. Give me 2 seconds to get back on track. Back at the dry run here. So we're at, I made this a little too complicated. I is equal to 2. So let me do it this way. Oops. A, B. I'm gonna need a better way to do dry runs.